start. Okay, so this is given by m varying from 0 to n minus 1, x1 of m multiplied by x2 of n minus m modulo n. So in our case, x3 of n is what? Nothing but summation small m varying in case of circular convolution, okay, maximum length of a given sequence. In this example, the length of x1 is 4, the length of x2 is also 4. So obviously the maximum length n would be equal to 4 only. Now say for example in the examiner will give you a sequence x1 of n whose length is 4. Similarly, examiner will give you a sequence x2 of n whose length is what? Say for example 7. In that case, what should you people choose the value of n as? In case of circular convolution, always the value of this capital N is chosen as to be the maximum length among the two given sequences. In these two given sequences, the maximum length is 7. Therefore, the value of n is equal to 7. If it is so, you should ask me a question, madam. In sequence x2 of n, there are 7 samples, no issues. But whereas in sequence x1 of n, there are only 4 samples. Then how to go about? For the remaining 3 samples, 5th sample, 6th sample, and 7th sample, you are required to what? Add zeros, and then continue. Is it clear? This is what the case of circular convolution. How you are doing in linear convolution? In case of linear convolution, if the value of the length of the first sequence is 4, second sequence is 7, the length of the converged sequence is what? Length of sequence 1 plus length of sequence 2 minus 1. So in that case, what is the length of sequence 1? Is 4. What is the length of sequence 2? 7 minus 1. So 7 minus, what is that? 7, okay, yeah, 7 plus 4 is 13. 13 minus 1 is what is called as 12. So the value of n will be 12. Sorry, 7 plus 4 is 11 minus 1 equals 10. Okay, so in case of linear convolution, the value of n is 10, but whereas in case of circular convolution, the value of length n is basically what is called as 7. I'm going to choose the maximum length. Clear? So in the present context, length of sequence 1 is 4, length of sequence 2 is also 4, so no issues. The value of n is 4. 4 minus 1 is 3. x1 of m into x2 of n minus m index 4. Yeah. Now we should proceed. See, circular convolution can be solved in 3 different ways. The first method is called as concentric circular method. The second one is called as the matrix method. The second one is called as matrix method. The third one is computation of circular convolution using DFT and IDFT method. So in the exam, both theory as well as practicals, whenever they ask you to perform circular convolution, you can use any one of these 3 methods, provided the examiner has not insisted you on for which method has to be used. Okay? So what we'll do is we'll just solve the same problem in all the 3 methods, or we'll pick different problems for these 3 methods. Is it clear? So we'll go for the first method called as concentric circular method, CC method, concentric circular method. Shall we proceed? All of you are there?
Yes,
ma'am.
Yes,
ma'am.
Can anybody say what is x1 of n? I have to scroll the page up. What is x1 of n quickly? Read out the sample values here. What is x1 of n? 2, 3 minus
2, 3 minus 1,
3,
2.
-1, 4. You should be quick, yeah. Your people are doing the sheets, right? Read out to me. 2, 3, -1, 4. What is x2 of n?
7, 8, 5, minus 6.
5 minus 6.
7, 8?
5, 5,
5 minus
5.
Okay, 5
Minus
and
6.
7, 8, 5 and -6. Yes, done. See, very simple, okay? First, I'll just teach you the actual formula and then teach you the simple trick also. So, what is the formula? So, according to a formula, what is that? x3 of n was what, yeah? Summation small m varying from 0 to n minus 1 was 3. x1 of m into x2 of n minus m modulo 4. So the first step is translate the sequence x1 of n and x2 of n to what is m domain. M domain means instead of indices being n, it has to be indices m. So how does x1 of m looks like? For example, say if this is x1 of m, x1 of m. So how do you people represent x1 of m? It is basically what? 2, 3, -1 and 4. Please remember that we are using the anti-clockwise direction to be the positive direction. This is how I represent x1 of m. Similarly, represent x2 of m also, x2 of m also. Basically what? 7, 8, 5 and -6 done. So after translating the two sequences onto the n domain, next, what is the range? Okay, what is the range of n? N varies from 0 to m minus 1, what is called as 3. For the first case, when the value of n is equal to 0. So what is x3 of 0? x3 of 0 is nothing but summation small m varying from 0 to 3 x1 of m into x2 of the value of n is 0 minus m modulo 4. So this is nothing but summation small m varying from 0 to 3 x1 of m. I'll write this as x2 of minus m modulo 4. What are this old sequence represents here? x2 of minus m is, how do I convert x2 of m to x2 of minus m? Just time reverse the sequence. x2 of m. So what do you mean by time reversal of the x2 of m? What was sample 7, 8, 5, -6, right? So see, if what is that? If x2 of m was equal to what is that? 5, so just 7, 8, 5, -6, 7, 8. Okay, 1 second. This is what? 7, 8, 5, -6. Come right. You know the okay. 7, 8, 5, -6, 7, 8. 1 second. It is 7, 8, 5, -6. Yeah. 1 second. So it is. It is 7, 8, 5, -6. If I say, if I've represented this particular sequence in the anti-clockwise direction, if I have to revert the sequence as x2 of minus m, what you must do is on the circular scale, you start from the first sample 7. Instead of going in the direction 7, 8, 5, -6, what I must do is just revert the sequence in the anti-clockwise direction. So what happens there? Instead of starting from the sample 8, you must start from the sample -6. 7 is basically what? -6. Then basically what? 5. Then basically what is called as? This is what is called as? Is it clear? 7, 8, 5, 6. 7, 8, 5, 6 was the actual sequence. Now you must rewrite this as starting from 7 as it is. Instead of starting from 8, what I must do? Start from -6, then 5, and then it's called as 8. This is x2 of m, and this is x2 of minus m. This is what is called as x2 of minus m. Is it clear? This is the first step. The first step was to represent the two. What's that? Sequences on the circular domain x1 of n, x1 of m and x2 of m. In the second step, to get x2 of minus m, what you must do is just revert the sequence. Instead of going in the the anti-clockwise direction, you must come in the clockwise direction. Instead of going as 7, 8, 5, and 6, come in the clockwise direction. 7, 8, 5, and minus 6. What does this whole equation says? I have to go on varying the value of m from 0 to 3 and take the product of x1 of m with x2 of minus m modulo 4. The very value of x2 of minus m modulo 4 is circular shifting the sequence with index modulo 4. So to make it more simpler, okay, as the very name suggests, if it is what is called as concentric circular method means do like this. 1 second. Okay, so first draw an outer circle. Okay, mark this as your x1 of n sequence. What was the x1 of sequence? 2, 3, minus 1, 4. 2, 3, minus 1 and 4. Okay, mark like this. 2, 3 and minus 1 and what is called as 4. What is called as 4? Please note that this is your x1 of m. Now what I want for n is equal to 0, x1 of m has to be multiplied by x2 of minus m modulo 4. Minus m modulo index 4. Okay. So again draw an inner circle. Please note that this is nothing but your x2 of minus m modulo 4. How does the sequence looks like? Instead of going in the anti-clockwise direction, what I must do now? Mark the samples in the clockwise direction as what we have done over here. 7, 8, 5, minus 6. So this is your 7, this is your 8, this is your 5, and this is your minus 6. So now, therefore, x3 of n is what? Since in this case, the value of n is 0, x3 of 0 is multiply the corresponding samples. 7 into 2 is what? 14 plus 6 into minus 6 into 3 is what? Minus 18. Then it is what? 5 into minus 1 is what? Minus 5. Lastly, 8 4s are 32. May I know what is the answer for x3 of 0? x3 of 0, 14 minus 18 minus 5 plus 32.
23.
23.
Yes, that is the first value. Similarly now, at n is equal to 1, what does the formula says? The formula says, again we just want to recollect the same formula. Recollect the same formula over here. So, x3 of 1 is nothing but summation, small m varying from 0 to 3. x1 of m, please do not disturb it as it is in this case. x2 of, please note that the value of n is 1 minus m modulo 4. The same thing can be also written as, sorry for your usuality, m varying from 0 to 3 is nothing but x1 of m multiplied by x2 of minus of. I'll write this as basically minus of. If I could just do one thing. If it's very confusing, okay, let me not introduce this to you people at all. A few of you might feel very confusing. I'll not just introduce this at all. Let's make it more simpler. Yeah. By this whole equation, what you must do is, okay, again from the previous concept, take the first circle as it is, x1 of m, the values are the same. It's what? 2, 3, minus 1 and 4. The values remain the same. 2, 3, minus 1 and 4 as it is. Okay. Coming back to the inner circle, what does it mean? x2 of 1 minus m4 means this particular sequence x2 of minus m has to be shifted by an interval of 1. See, the first case for n is equal to 0. What did I do? How did I get x2 of minus m? By representing the samples in the clockwise direction. 7, 8, 5, 6 was represented in the clockwise direction. Now, whatever sequence I've got, if I have to introduce a shift of 1, go on shifting the samples by one term in the anti-clockwise direction. In the anti-clockwise direction, what happens then? It's a 7, -6, 5, and 8. Is it so? It should be 7. So we start from 7 now. 7, okay, yeah. This 7 comes over here, -6 comes over here, 5 comes over here, and 8 comes over here. So what happens? Instead of starting 7 from over here, I'm going to start 7 from over here, then comes -6 over here, then comes 5 over here, then comes 8 over here. Please note that in the earlier sequence, how was my x2 of -m? This was 7, this was -6, this was 5, and this was 8. Please compare this circle with the inner circle. What I've done, I've shifted this 7 by 1 unit in the anti-clockwise direction. Therefore, 7 comes over here, -6, 5, and 8. Now, therefore, what is x3 of 1 now? Just multiply the respective sample indices. 8 2s are 60, 7 3s are 21, -1 into -6 is +6, 5 4s are 20, 5 4s are 20. May I know what's the value now?
63.
63.
63. That we are done with that. That's it. Now, similarly, we'll go for now. What is that? X for n is equal to 2. For n is equal to 2. X3 of 2 is given by summation small m varying from 0 to 3. X1 of m as it is. X2 of, in this case, the value of n is 2. It is 2 minus m modulo 4. 2 minus m modulo 4. Again, what you must notice, the first sequence as it is no change. What's the first sequence? 2, 3, -1, 4. Those samples are the same. 2, 3, -1, and 4 as it is. Now, what I must do to get a shift of 2? Okay, go back to the previous diagram. Again, what you must do? Right shift by 1. My starting sample was 7. It has come by over here. Again, right shift by 1. Or if you want to start from the 0th index only, shift 8 over here. 7 comes here. -6 comes here. 5 comes here. Is it clear? So it should be what now? 8, 8, 7. Okay, I'm going to start from over here. 8, 7, -6, 5. So it is what? It comes like this. 8, sorry. Where was that? Okay, 8, 7. Yeah. This should be, yeah, 8, 7. This should be -6. This should be 5. So what I've done is, now this 8 has been shifted by 1 term towards the anti-clockwise direction. It was 8, 7, -6, 5. 8, 7, -6, and 5. That's it. So therefore, x3 of 2 now will be equal to 5 2s are 10, 8 3s are 24, 7 into -1 is -7, 6 into 4 is -24. Therefore, the value of x3 of 2 is, I think the value is 3. Value is 3. Lastly, for the last sample, n is equal to 3, the last shift we must do, x3 of 3 is nothing but summation small n varying from 0 to 3, x1 of m multiplied by x2 of, the value of n is 3, 3 minus m modulo 4. What you must do is, again, the outer sequence will remain as it is. 2, this is 3, this is -1, and this is 4. Now 5 has to come over here. 5 has to be shifted once. 5, then comes, okay, 8 comes here, 7 comes here, -6 goes over here. So 5 comes over here, 8 comes here, 7 comes over here, and -6 comes over here. That's it. Therefore, x3 of 3 is nothing but -6 into 2 is -12, 5 3s are 15, -1 into 8 is -8, 7 4s are 28. Therefore, x3 of 3 is equal to
23.
23.
how much? 23?
Yes, ma'am. 23. Yes, ma'am.
Sorry, I'm not able to hear you people. Is it when? Is this 23?
20.
Yes, ma'am.
Yes, ma'am.
ma'am.
23.
23. Oh, that's it. So therefore, the resulting values was that x3 of n was what? Circular convolution of x1 of n with x2 of n, and the resulting samples are, what was x3 of 0 quickly? x3 of 0?
23.
23.
23.
23. 23, ma'am.
Read out the value because I can't. x3 of 1, how much you people had got earlier?
63.
63.
63. x3 of 2,
63.
x3 of 2,
3.
63.
x3 of 3,
3.
of 3, and yes, that's it. 3 and 20.
20.
That's it. Is it clear? See, first time you're learning it, if it takes time, if you could know the trick, it's a matter of 2 or 3 minutes solution. Okay? We'll do it. What we'll do is I'll just take one more simple example and directly draw the circles and do it. Everybody knows the formula. Okay, I'm not using the formula. Just directly use the concentric circle method and do the solution at one shot. And everybody must give the answers at the earliest. Okay, we'll just try one simple problem quickly. I'll define x1 of n as, say, 1, 2, 2, minus 3. I'll make this as 6, so it shouldn't be very confusing. Okay, I'll just make this 1, 2, 4, minus 3, and x2 of n as what? Say 3, minus 2, 7, 4. Is it clear? But please see, in the exam, the formula is must. First, once write off the formula, and then you can go for your circular convolution method using the concentric circle phenomenon. x3 of n is given by summation small m varying from 0 to n minus 1, x1 of m into x2 of n minus m modulo n. Write off this formula, writing the formula will fetch you 1 mark in the exam. So it is 3x1 of m into x2 of n minus m modulo 4. So afterwards, I'm not writing the formula, I'm just using the circular phenomenon. But in the exam, against each concentric circle, you are required to expand the formula also. Write the formula and then write the corresponding concentric circle diagram. Okay, so case 1, when n is 0, so what is the first method? Yeah, first method is what? The first circle is what? Yeah, the first circle is x1 of n. What you must do? Okay, write them in the anti-clockwise direction. 1, 2, 4, and minus 3. First circle as it is in the anti-clockwise direction. See, according to us, anti-clockwise is the positive direction. Is it clear? Yeah. What I must do for second circle? The second circle has to be written in the clockwise order. So we'll start from what? Start from 3. Instead of going in the anti-clockwise, come in the clockwise. 3. Then what? Minus 2. Then 7, and then it's what? 4. Is it clear? First sequence in the anti-clockwise direction, second sequence in the clockwise direction. So the value of x3 of 0 is what? 3 into 1 is 3, 4 2s are 8, 7 4s are 28, minus 2 minus 3 is plus 6. What is the answer?
45.
45.
45.
Okay. You must do it at a better speed than me. You're using a pen and paper. So what happens to case 2? For n is equal to 1, please note that the outer sequence remains the same. 1, 2, 4, and minus 3, no change. But what happens to the inner sequence? You must go on shifting the samples by a unit of 1 in the anti-clockwise direction. So I must not start 3 from here. We start 3 from where here? From here. 3, 4, then what? 7, then what? Minus 2. Is it clear? Then, so what is x3 of 1 would be equal to minus 2 into 1 is minus 2, plus 3 2s are 6, 4 4s are 16, 7 into minus 3 is minus 21. Yes. So what
Minus
is
1.
-1.
The answer is minus?
1.
1.
Okay, fine, no problem. Let's stick on to it. Next. Now case 3. Case 3 is what? When the value of n is 2. The value of n is 2. The outer sequence as it is 1, 2, 4 and minus 3 as it is. The inner sequence again shift by 1 unit towards the right hand side in the positive direction. This was minus 2, right? This was minus, yeah, minus so. So minus 2 comes here, 3 comes here, 4 comes here, 7 comes here. So therefore, x3 of 2 would be equal to what? 7 into 1 minus 2 to 2 is 4, 4 3s are 12, 4 3s are minus 12. I think the value of x3 of 2 is equal to what? 3. Is equal to what? 3.
3.
The last case now. This I'm doing it at a bit fast pace because you know the method now. Just for practice. N is 3. What I must do now? Again, the outer samples as it is 1, 2, 4 and minus 3. Minus 3 as it is. The inner samples again shift in the anti-clockwise direction. This is becomes 7. This becomes minus 2. This becomes 3. This becomes 4. So therefore, x3 of 3 is what? 4 into 1 is 4. 7 2s are 14. Minus 8 minus 9. Therefore, x3 of 3 is
1.
is it 1?
Yes,
ma'am.
Fine. Done. So what you must do is ultimately just jot down the sequence. Therefore, x3 of n is, what was x3 of 0? 45, is it? Okay.
Yes, ma'am. 45.
45, yeah. It's 45. Then was what? Minus 1, then 3, and then 1, then 1. Is it clear? Now, we'll solve the same problem. The second problem is quite much more easier. Using what? Using the matrix method. Using the matrix method. All of you are ready? Any doubt the first method? Students?
No,
ma'am.
No, ma'am.
No, ma'am.
We'll go for
No, ma'am.
method 2, which is called as matrix method. This method is much more simpler and less time consuming. Less time consuming. Okay. So for this, again the same formula holds good. What does the formula says here? The formula says x3 of n is what? Summation small m varying from 0 to n minus 1 x1 of m into x2 of n minus m modulo n. Same thing. Okay. So in our case, okay, what was, okay, please read out the second problem as it is. What was x1 of n? 1, 2, 4 and minus 3, is it? Yeah. It was what? 1, 2, 4 and minus 3. Can anybody read out what is x2 of n?
3 minus
Eshtama?
3 minus
You're not audible. What is x2
Three.
of n? 3 minus 2, 7, 4.
3 minus 2, 7 and
3, what is that? 3 minus 2,
Minus 2,
7 and
7
4.
and 4.
Okay, done. Next. Okay. Now, how to use a matrix method? It's very simple. You must make 3 columns. There's not columns. Actually, like visualize 3 columns. x3 of n, the first column heading. The second column heading should be x2 of n minus m modulo. In our case, it is what? 4. Value of n is what? 4. And the first one is what? x1 of m as it is. Okay. So now what I want the samples x3 of n. This is a blank to me. This is equal to, okay. Visualize this as a matrix, and we also want to visualize this as a matrix. This is a matrix method. So what is my x1 of m? x1 of m. The same thing, instead of n domain, you must visualize m domain. No issues. It's n, m or k domain. Doesn't matter to me. So just draw down the sample values as it is vertically. It's what? 1, 2, 4 and minus 3. Is it clear? Do not disturb the first sample, x1 of m as it is. Okay, as it is, no change. Next, what is this? x2 of n minus m modulo 4. See, while using the concentric circular method, what was the first step here? The first sequence was maintained as it is. The second sequence was plotted in the clockwise direction because the value of n was because the value of, where is that? Yeah, the value of n is 0. Means what happens? x2 of minus m modulo 4. So what I must do? I must write the sequence horizontally in the time reverse format. So what is my x2 of n? 3 minus 2, 7, 4, right? So how do people write this as? Instead of starting from the starting from this order, go from this order. The first sample is 3 as it is. Instead of writing minus 2, what you must do? Start from this. It's what? 4, then 7, and then minus 2, and then minus 2. Is it clear? The first sample, no change. The first sample, no change. Instead of starting from this sample, start from the last sample. 3, 4, and then 7, and then minus 2. Okay, so that is what the elements of the first row. In the second row, what you must do is go on shifting these elements in the cyclic fashion. Whatever was the last element becomes the first element, minus 2, then 3, then 4, then 7. Again, this last element 7 comes over here. 7, minus 2, 3, and 4. Again, this last element comes here. 4, 7, minus 2, and 3. So again, if I put here 3, I get back the first row. So 3, 4, 7, and minus 2. So that is where you must stop. That is where you must stop. Now what you must do here, multiply the first row by the first column, you get the first element. Second row, multiply to the first column, second, third row into this, third element, fourth row into this, reduce by the fourth element. Could you guys try it out? Give me the answer. What is the answer? What is x3 of 0? 3 into 1 plus 4 into 2 plus 7 into 4 plus 2 into 3. Minus 2 into minus 3. Any confusion writing this matrix? Please note that the first sample 3 has to be maintained as it is. Instead of starting from the very immediate sample, go to the last sample, the reverse, because I'm writing the sequence in the clockwise direction. To start the last sample, 4, then 7, and then minus 2. 3 into 1, for the first element, 3 into 1 plus 4 into 2 plus 7 into 4 plus minus 2 into minus 3. Do I get back 45 only? Students?
Yes, ma'am.
Yes, ma'am.
Yes,
That's
ma'am.
45. Again, second row into first column. Check it out. Don't just say it blindly. Check it out.
Yes, ma'am. Minus 1.
Minus
This is
1.
minus 1.
Yes, ma'am.
Yes,
The
ma'am.
third one, third element.
3,
X2
ma'am.
of 2.
3, ma'am.
Is it 3 only?
Yes, ma'am.
Yes, ma'am.
Is it 3? The last element, is it plus 1 only? Check it out. Everybody must do, even the boys or there.
1, ma'am.
1. That's it. So therefore, these are the elements of x3 of n. x3 of n is, what is that? 45, comma, minus 1, comma, 3 and 1. See the amount of time you can save over here. It's pretty simpler and the quickest method. If the examiner doesn't specify which method, it's your choice to use any method. Is it clear? Is the second method clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Can we go on to the third method? If anybody has got to require any clarification, got to ask something, you can ask me. The third method is called as circular convolution using the concept of DFT and IDFT. Shall we start? Yes, we should start.
Yes, ma'am.
Yeah. And please, you please follow it carefully, okay? Yeah, because this is the first time, because the same concept will be also taught in your MATLAB. So if you could understand here, that programming becomes much more simpler. So understand over here, okay? Now, because it's involved a lot of multiplications, I'll take all positive values only. If you want to try it for the previous problem, you end up in the same answer. Assume x1 of n to be some sequence, say 2, 3, 1, comma 1. Take it down. And x2 of n, some arbitrary sequence here. 1, comma 3, comma 5, comma 3. Everybody must do it along with me. Just don't see the screen at your place. Take a pen, paper, and do it with me, along with me. Yes. Now the first step is, yeah. What is that? You must visualize this sequence x1 of n and x2 of n. Okay. See, if you could ask me to plot how does x1 of n looks like, it is something like this here. At index 0, at index 1, at index 2, and at index 3. The plotting of x1 of n. At index 0, what I've got? I've got an impulse of weight 2. At index 1, what I've got? I've got an impulse whose weight is 3. At 2, I've got an impulse whose weight is 1. At index 3 also, I've got an impulse whose weight is 1. Is it clear? This is how x1 of n looks like. Similarly, how does x2 of n looks like? How does x2 of n looks like? Same at indexing 0, at indexing 1, 2, and 3. What I've got indexing 0 here? An impulse whose weight is 1. What I've got indexing 1? An impulse 3. An impulse whose weight is 3. At 2, what I've got? An impulse whose weight is 5. Again at 3, I've got an impulse whose weight is 3. Is this concept clear? This is how we visualize the sequence x1 of n and x2 of n. What is x1 of n? Nothing but the sum of weighted impulses. x1 of n and x2 of n are nothing but the sum of weighted impulses. Now, can anybody translate that graph to an equation? What is x1 of n? Quickly, 5th A students. Yes, yeah, you have learned, right? Signals and systems. You should know how to translate the graph to an equation. What is x1 of n? The answer is there in the graph. What is x1 of n? Quickly. Yes, what is x1 of n? What is this? What I've got? An impulse whose weight is what? 2. 2. What I've got? An impulse. Where is the impulse placed? At index 0. This is what? 2 times delta of n. Next, I told, right, sum of weighted impulses. At index 1, what I've got? An impulse whose weight is what? 3. Weight is 3. I've got impulse. Where is the impulse placed? Right shifted by an interval of 1. Delta of n minus 1. Next, what is the weight of this impulse? 1. 1 is 1 only. Okay, fine. This impulse placed right shifted at an index 2. The last sample, weight is 1. Weight is 1. What is its impulse placed at? Impulse being what placed at 3. Is it clear? This is how I represent x1 of n. I represent x1 of n. Now, how do I get how do I translate x1 of n to what is called as x1 of k? If you ask, madam, what is the need of, since I'm doing the circular convolution in time domain, why am I shifting from time domain to frequency domain? If you people could recall that multiplication property, it states that x1 of n circular convoluted with x2 of n, it forms what? It forms an n-point DFT pair with what? x1 of k multiplied by x2 of k. I'll repeat once again. If I could circularly convolve the two sequences in time domain, it is equivalent to what? Multiplication of the respective DFTs. So what I've got now? I've got x1 of n. I must what? Circularly convolve with x2 of n. To make my procedure easy, or if examiner insists, use a DFT, IDFT method, what I must get? What I must do? Obtain x1 of k from x1 of n. Obtain x2 of k from x2 of n and multiply the two DFTs. If it is so, that is, I get what? By doing so, for example, say, if x1 of n is circularly convoluted with x2 of n if the resulting sequence is x3 of n. X3 of n is said to form what? An n-point DFT with, say for example, x3 of k. What is x3 of k? Product of x1 of k into x2 of k. So from x3 of k, how do I get back x3 of n? Obtain its IDFT. The IDFT of x3 of k will give me what? x3 of n. Now, what I must do now? Do the product of x1 of k into x2 of k. I've got x1 of n. How do I get x1 of k? Must say, madam, should we use formula method or should we use that linear transformation method? That's all fine. The direct way of getting the DFT for a given sequence x1 of n, provided, please note this sentence, hear this sentence carefully. The DFT of the given sequence x1 of n can be obtained directly, provided if x1 of n is represented as what? Sum of the weighted impulses. How, miss? Probably you can just recall, we have done this. What is x of n? X of n is said to form what? An n-point DFT pair with x of k. If my x of n is delta of n, its corresponding DFT is equal to 1. We have done this in the very few initial classes. The DFT of impulse is always equal to 1. And if the same impulse has been what? Shifted by an interval of n naught, okay? Its corresponding DFT, the answer is W to base n to the power n naught into k, Is it clear? So if an impulse is the what time shifted by an interval of n naught, its corresponding DFT can be represented in terms of Twiddle factor as what? Wn raised to the power of this shift n naught multiplied by k. Now what I'll do? I'll be applying this property directly to my above sequence x1 of n. So its corresponding DFT x1 of k is nothing but, what is that? 2 as it is, 2. What is the DFT of delta of n here? DFT of delta of n is what? 1. So 2 into 1 is what? Basically it's 2 only. Plus, what is that? That coefficient weight 3 as it is, 3 as it is. What is delta of n minus 1? See, what is the value of n naught here? The value of n naught is basically what? 1. Delta of n minus n naught. The value of n naught is what? 1. What is its corresponding? DFT? W. May I know what's the value of capital N? What is the length of the sequence? 4 only. What's what? W4. What's the value of n naught here? N naught is what? 1. 1 into k is k. Next term. 1 is what? Coefficient as it is. Delta of n minus 2 is what again? W. The value of n is always 4. The value of n naught here is what? 2. It's what? 2 times k. Plus. Again, delta of n minus 3 is what? W4. The value of n naught is 3. 3 times k. Is it clear? Provided you can write this directly what? If x1 of n is represented in terms of impulses only, sum of weighted impulses only. Is it clear? So this is the DFT of x1 of n. Any doubt over here? Any doubt, anyone?
No, ma'am.
Yeah. Now can do it for x2 of n now. x2 of n, shall we start? What was x2 of n sequence? 1, 3, 5, 3. 1, 3, 5, 3. Okay? We'll just first write the sequence x2 of n. Write sequence x2 of n. So what is x2 of n? Yeah. x2 of n. What's the first weight? 1, right? 1 times delta of n. 1 times delta of n. Then it is what? 3 times delta of n minus 1 plus what? 5 times delta of n minus. Then it is what? Now is what again? 3 times of delta of n minus 3. Is that clear? I've translated this graph or the sequence as the equation. Accordingly, if I would apply the DFT to this, it's what? x2 of k. x2 of k. DFT of delta of n is always 1. 1 into 1 is 1. 3 times. What's the value of n naught here? Again 1. 3 times W4 to the power of 1 into k is k. Plus 5 times W4 So what's the value of n naught here? 2. It's 2 times k plus 3 times w. The value of n is always 4. Capital N is 4. The value of n naught is 3 over here. It is 3k. 3k. Okay. Now I've got what? I've got x1 of k. I've got x2 of k. What does this, the rule says? What is x3 of k now? X3 of k is nothing but x1 of k multiplied by x2 of k. If there is no doubt till now, I'll proceed to the next step. Any doubts you can ask me? Any doubts, students? Matadroil.
No, ma'am.
No, ma'am.
No, ma'am.
Are the boys doing the problem? The boys, 5th A?
Yes, ma'am.
Only Elvin speaks. Probably is the only boy to be present in the class. I don't understand. Yes. Now, so we'll just complete off this part. Now for x3 of k, what is x1 of k? I'll just take down the sequence as it is. 2 plus 3 times of w4 to the power of k plus w4 to the power of 2k plus w4 to the power of 3k multiplied by, what is x2 of k? 1 plus 3 times w4 to the power of k plus 5 times w4 to the power of 2k plus 3 times w4 to the power of 3k. Yes. Okay, this is what plain multiplication, nothing else here. Plain multiplication. Okay, therefore x3 of k, take the first term over here, multiply to all the terms over here. Then second term with all the terms, third with all the terms, fourth with all the terms. We start the first term, 2 into 1 is what? 2 plus 2 into 3 is what? 6. 2 into 3 is 6. W4 to the power of k as it is plus 2 into 5 is what? 10. W4 to the power of 2k as it is. 2 3s are 6. W4 to the power of 3k as it is. Is it clear? The first term is multiplied with all the terms present in the second bracket. Next, I'll take the second term in the first bracket to multiply with all the terms in second bracket. 3, the first term into this 1 is what? Please check out the coefficients. So I'll write the corresponding coefficients beneath only. 3 into 1 is 3. 3 into 1 is 3. 3 times W4 to the power of k. Then it's what? 3 into 5 is 50. 3 into 5 is, okay, yeah, this is what? Sorry. 3 into 1 is 3 done. Next 3 into 3. 3 into 3 is 9. 3 into 3 is 9. W4, see, please note that over here, W4 to the power of k into W4 to the power of k is what? W4 to the power of 2k, exponential or formula. Next is what? 3 5s are 15, 3 5s are 15. W4 to the power of k into W4 to the power of 2k is W4 to the power of 3k. The next term is 3 3s are 9, 3 3s are 9. W4 to the power of k into 3k is W4 to the power of 4k. Done with the second term. Next, the third term. The third term here. 2 into 1 is 2. 2 into 1 is 2. This means what? 2. This is nothing but 2 times. Sorry, what is that? Okay, yeah. W4 to the power of 2k into 1. So it is W4 to the power of 2k as it is. Then it is 1 into 3 is 3. W4 to the power of 3k. Next, it is what? This term into this term. 5. W4 to the power of 4k. The last term. This term into this is what? 3 times of W4. Please note that this should be W4. If I've done anything wrong on the board, please kindly let me know. This should be W4. W4, this should be W4. So it's what? The last one is what? W4, but this is W4 to the power of 2 plus 3 is what? 5k. Now we're left with the last term into all the terms. 4, so the term 4 comes over here, the last term, W4 to the power of 3k, then again it's what, 3 times W4 to the power of 4k, then it is 5 times W4 to the power of 5k, plus 3 times W4 to the power of 6k. Yes. Any doubt for anyone? I just multiplied every term, the corresponding terms in the second bracket. Any doubt over here? Students, any doubt, please ask. Do not hesitate. In any of the terms written over here, any doubt, anyone?
No, ma'am.
No, ma'am.
No, ma'am.
Yeah. Yes. Okay. Now, see now, what is the value of n here? The value of n is 4, right? The value of n is what? 4. So please note that. See, this is the first problem, so I'm writing everything elaborately. Hence, afterwards, you people can cut short few things, as how I'll say. So the first term as this what? 2 plus 6 times W4 to the power of k plus 10 times of W4 to the power of 2k plus 6 times of W4 to the power of 3k. First row, nothing as it is. Coming back to second row. What is that? 3 times of W4 to the power of k as it is, plus 9 times of W4 to the power of 2k as it is, 15 times of W4 to the power of 3k also as it is. Coming back to this, what is W4 to the power of 4 is equal to always? W4 to the power of 4.
1.
Is equal to 1. There is nothing but what? W4 to the power of 0, isn't it? As people told, W4 to the power of 4 is always equal to 1. That is nothing but W4 to the power of 0 is equal to what? 1. So what does this whole term tends to? Please note that this whole, where is that? Yeah. This whole term tends to 1 into 9 is 9. So I'll carry that 9 over here directly. Is it clear? Is it clear? W4 to the power of 4 is 1. 1 into 9 is 9. No issues. Next, coming back to the third row. What's this term? This term is what? W4 to the power of 2k as it is. 3 times of, what is that? W4 to the power of 3k as it is. Next, come back to this term here. Again, W4 to the power of 4k is what? Again what? W4 to the power of 4 is basically 1. So 1 into 5 is 5. So this becomes 5 over here. This becomes what? 5 over here. What about this term? W4 to the power of 5k is what? See, please note that. W4 to the power of 5k, by using the periodicity property, this is nothing but W4 to the power of k. Is that fine? It goes like this. 0. Okay, I'll write over here for all those who have forgotten. It goes like this. 0, 1, 2, 3. Again, word repeats. 4, 5, 6, 7. 8, 9, 10, 11. Please note that W4 to the power of 5k is equal to W4 to the power of 1k. W4 to the power of 6k is equal to W4 to the power of 2k, and so on. So what is this term? W4 to the power of 5k is equal to what? W4 to the power of k. So I'll write this word, I'll write this over here. 3 times of W4 to the power of k. Coming back to the last row, the last row is what? The last row is W4 to the power of 3k as it is. As I told you, W4 to the power of 4 is 1. 1 into 3 is 3. Done. Then W4 to the power of 5 is what? W4 to the power of 1k. So write this over here. 5 times W4 to the power of k. And W4 to the power of 6 is what? W4 to the power of 6 is but W4 to the power of 2k to the power of 2k. That is why it comes over here 3 times W4 to the power of 2k. Is it clear, students? Is it clear? As we get on to the higher powers of n, use the property of periodicity. Now, could anyone quickly add up? I think we're running short of time. I want to finish this problem. Now, give me what about the solution of all this? to add all this, how much do I get? 9 plus 5, 14, plus 2, 16, plus 3, 19. Quickly, next. What is 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 5 is what? 17. 17 times W4 to the power of K. If I'm right, if I'm wrong, let me know. 10 plus 9 is 19, plus 1, 20, plus 3 is 23. 23 W4 to the power of 2K. The last one, 15 plus 6 is 21, plus 2, 24, plus 1, 25. 25 into W4 to the power of 3K. All you must add the respective terms of K. W4 to the power of K. Is it clear, students? Any doubt? Artha aagte idya?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Therefore, lastly, see now what I want. I'm in frequency domain. Now what I must do? I must come back to my time domain. If x3 of k is so much, if I have to translate back to time domain, again what recall this property are delta of n minus n naught set to form dft of what? Wn to the power of n naught into k, n naught into k. The first term is what? 19 as it is. Since it is not having any middle factor term, it's what? 19 times delta of n plus 17. What is the coefficient of k over here? 1. So it's the value of n naught 1. If it's what? Delta of n minus 1 plus 23 times delta of, what's the coefficient of k? 2. What is 2? N naught. N minus n naught is 2 plus 25 into what is that? Delta of n minus n naught is 3 over here. If it is so, now just collect the samples. Therefore, x3 of n is nothing but what? 19, 17, 23, 25. Is it clear? This is how we do using DFT, IDFT. Now, I'll give you 2 minutes time. Use the matrix method. Use the matrix method, and I want a verification by next 2 minutes. How will people do that? Quickly. This is a matter of, okay, 2 minutes only. Everybody quickly do this. Just for verification. Yeah. What was the x1 of n? What was the x1 of n? Where was the sequence? This will get back. When was that? Yeah. What was x1 of n? 2, 3, 1, 1. 2, 3, 1, 1. So write down quickly. It's 2, 3, 1, 1. I have to just get back my original sequence. So what is x2 of n? 1, 3, 5, 3. 1, 3, 5, 3. So please note that x2 of n was how much? 1, 3, 5, 3. Am I right? Just once cross check, should not be wrong. Somebody must say me, I'm trying to scroll
Yes,
up and
ma'am,
down.
yes, ma'am.
How do people read a sequence for me? Everybody must participate here. You should have an interest. So how will you write?
Yes,
1 as it is. Don't start from this 3, start from this 3. 3, then 5, then 3. You see, in this case, the values are matching, but please don't get confused. First, this is first sample, this is second, this is third, this is fourth. 1, 3, 5, 3. Then what? Circularly shift. 3, 1, 3, 5. Again, circularly shift. 5, 3, 1, 3. Again, what? 3, 5, 3, 1. Yes, students, multiplied into the values. Are the values same? This is nothing but your x3 of n. This is nothing but what was this? x2 of n minus m modulo 4. This is your x1 of m. Everybody must do with interest. Then only the verified should be the same.
Yes, ma'am. It's matching.
It's matching. The same answer. X3 of 0 is 19.
Yes, ma'am.
It is 17. Is it 23 and 25?
Yes,
Yes,
ma'am.
ma'am.
Yes,
How many
ma'am.
of you did this one? Hardly, I can count 10 or 12, probably. Other students? I have no idea. Huh? Okay, fine. I can't force the people. Those who want to learn will learn. Probably when people come back, is that internal marks or lab internal marks, staff will be not there to support you here. Until unless you people show interest in the class, staff cannot support you. Okay, fine. I'll stop it over here. I could just check that class strength, yeah. I don't know when they'll get in, when they'll come out, I'm not sure. Okay, fine, no issues. Okay, any doubts, please do get it cleared in the next class. The entire result, all the problem solutions of module 1, probably by today evening I should be able to complete it. I'll be uploading it in the Canvas. Is it clear? So Monday we start
Yes,
on
ma'am.
module 2. If time permits, Monday we can go to problems. Or there is any doubts, or else we can go for module 2. Clear, students?
Yes, ma'am.
Yes,
Fine.
ma'am.
Okay. Okay, but take care in the class. See you on Monday. Okay.
Thank you, ma'am.
Thank you, ma'am.
Bye. Bye.
Thank you, ma'am.
Okay.
Thank you, ma'am.